The first thing I'd like to do in this lesson is to review molarity. So take a moment and gather yourself notes so that you can find the formula for molarity. Okay, hopefully by this point you have gathered your notes and you have found that calculating molarity is that molarity, capital M, is equal to the number of moles of solute divided by liters of solution. So if you use that equation to answer this problem, it says if 4.5 moles of NaCl is dissolved in water to make 9.0 liters of solution, what is the molar? Well, 4.5 moles of NaCl is the solute. So capital M, which we're solving for, molarity is equal to 4.5 moles of NaCl divided by 9 liters of solution. Alright, so we solve this by taking 4.5 moles of NaCl and dividing it by 9.0 liters of solution, which gives us a molarity of 0.5 moles per liter, or just capital M. So my answer is 0.5 molar. The next review problem I want to do says if 11.9 moles of lithium nitrate, so because it says moles, we know this is the solute, is dissolved in water to make 0.622 liters of solution, what is the molarity of the solution? So again, M is equal to the moles of solute over liter of solution. So we plug in 11.9 moles of solute divided by 0.622 liters of solution, which if you plug it in your calculator gives you an answer of 19.1 molar. So go ahead and review these problems and your notes if you have any more questions about molarity. Moving on, we are going to begin talking about another form of determining the concentration of a solution called molality. So molality is a lot like molarity, except instead of measuring in units of moles per liter, molality measures in units of moles of solute, so that's the same, divided by kilograms of solvent. So whereas the molarity talked about liters of solution, now we're talking about measuring not only how much mass you have of your solute, but also the mass of the solvent. So essentially what you would do is you would have a container, you would add your powder to it, measure out the mass of that to calculate moles, and then you would add a certain amount of liquid until you had a total amount of mass. So now this is different because we're not filling to a line now. Now we're adding a certain quantity of solvent. But again, this is just another way to measure the concentration of a solution using moles. So a molal solution is prepared by using a balance to measure out the solid. So this is your solid. Because we can't measure in moles, we have to measure in grams and then convert to moles. And then we measure the solvent by using the balance also. So you're going to use the balance twice. So once to measure out the solid, then you'll zero it out again and then add solvent until you have a certain mass. So this time around, we don't have to worry about using glassware with marks on it or lines on it because we're not filling to a line. We're just adding a certain mass of solvent. So we're just going to use a balance for this. So this flask would be perfectly fine even though it doesn't have any lines on it. That's only if you're doing molality though, excuse me. Alright, so let's do a practice problem. This says molality practice problem number 1. If you have 2.45 moles of calcium chloride in 0.700 kilograms of solvent, what is the molality of the solution? Well, molality, we abbreviate with a little m, so that needs to go in your notes. Little m is equal to the moles of solute over kilograms of solvent. Not solution now, it's actually how much mass of solvent you add. So if you plug that in, it's 2.45 moles divided by 0.700 kilograms. Which, if you plug that into your calculator, gives you an answer of 3.5 molo. So 3.5 little m moles per kilogram. The second MOLO practice problem says if 7.65 moles of lead 2 nitrate is dissolved in 1.774 kilograms of solvent, what is the molality? So we've got our three variables here. Little m, molality, is equal to moles of solute over kilograms of solvent. So you plug that in and you get 7.65 moles divided by 1.774 kilograms, which, if you plug it into your calculator, gives you an answer of 4.31 molo, little m. Okay, so the last thing that we need to review is the comparison between molarity and molality. Well, molarity is abbreviated with capital M, and that is found by taking the moles of solute divided by liter of solution. So if you're given information that includes liter of solution, you will only be able to calculate molarity. That being said, little m stands for molality, and if you're given kilograms of solvent, you're only going to be able to solve for molality. Now with molarity, because we're not adding a certain amount of solvent, we are filling to the line, you have to use glassware that has marks on it. So that's really important. If you're going to calculate molarity or find molarity, you have to use glassware with lines on it. Now with molality, you don't have to worry about any lines on your glassware or equipment because you're going to use a balance. So really, like, none of these even matter. Like, you don't have to worry about having lines on them, because the most important tool for you to use is the balance when you're determining molality.